Hi students, welcome back to another lecture. Today we will be seeing Kirchhoff's current law. Okay, so something called circuit theory. Okay, we have already started circuit related things just by finding equivalent resistances, then finding EMF, finding terminal voltage or terminal potential difference. Okay, so in all these current division rule, voltage division rule, already we have started some circuit theory, but the core of current electricity is Kirchhoff's current law and Kirchhoff's voltage law. So once if we understand this topic and once if we start doing problems of this confidently, we can say we have reached a good level in current electricity. Because once if we know this, then any difficult circuit if we face, we will be able to solve it and come out of. So today I will be discussing the basics of Kirchhoff's current law. We will do simple problems, then we will move to different level of problems, different level of concepts. Okay, so Kirchhoff's current law, Kirchhoff's current law, we call them junctions rule also. Okay, Kirchhoff's current law we call junction rule also. So very first point which we need to understand is, suppose if this is a branch, this is another wire, this is another wire. Suppose 5 ampere current is coming like this, 2 ampere current is going like this, 3 ampere current will be going like this. So we will say entering current is equal to 5 ampere. Leaving current if we put, suppose if we put this as minus 5 ampere, entering current, you can take in any way. Lot of sign conventions will come in this topic, and any sign convention we can follow. Whichever way we do, we will come to the answer if we do it carefully. So I am taking this as minus 5 ampere, then leaving currents will be, one is 2 ampere, another is 3 ampere. So Kirchhoff's current law says algebraic sum of all the currents entering into a junction, leaving a junction will be 0. Okay, suppose if this is a junction, okay, this is a junction, what Kirchhoff's current law says is minus 5 plus 2 ampere plus 3 ampere is equal to 0. It is true now. This is plus 5, this is minus 5. So entering current we should put proper sign, leaving current we should take proper sign. If we take this as positive, these two if we take negative also, this will be correct. Okay, or what they are saying is, in other words, entering current will be equal to leaving current. Entering current is equal to leaving current. Suppose entering current if we take as 5 ampere, then this will be equal to leaving current 2 ampere plus 3 ampere. 2 ampere plus 3 ampere. Clear? Clear? That is what Kirchhoff's current law or junction rule. In short form we say KCL, KVL, Kirchhoff's voltage law, that is another one. Clear? This is just by putting values. Suppose if we name like this. This is I1. If this is entering, I2 is leaving, I3 is entering, I4 is leaving. We can say entering currents are I1 plus I3 will be equal to what? I2 plus I4. Okay, sum of entering current will be equal to sum of leaving currents. Or if we put entering current as minus, then even in this way also we can put suppose if I write this as entering current as minus, so minus I1 plus I2 minus I3 plus I4 is equal to 0. Sum of current will be equal to 0. Sum of current entering a junction will be equal to 0. Note it down. Okay, so KCL, suppose if we write the definition, okay, the sum of currents entering a junction is equal to the sum of current leaving the junction. Clear? Sum of current entering a junction is equal to sum of the current leaving the junction. This is the definition. Or simply we can say algebraic sum of current. Algebraic sum of current entering and leaving a junction is 0. Okay, so this is the definition of Kirchhoff's current law. Okay, clear? So what is a junction? If there are 2 or more branches, not 2, 3 or more branches, then we can say that is a junction. Suppose if this is a network, if we put some resistances here, okay, so this is a network. If we name this as A, B, C, D, A, B, C, D, E, F, then which is a junction? Which all are junctions? B and E are junctions. This is a junction, this is a junction. What about A, F, D, C? All these are nodes. Okay, so if we consider nodes, 2 or more branches are meeting somewhere, they are all nodes. So A, B, C, D, E, F. So these junctions are also what? Nodes. So this is simple node. Okay, this is called a simple node. Okay, so nodes A, B, C, D, junction is nothing but B, E. Clear? Note it down. So this is a junction. So first we saw what is KCL, just its concept. Then we saw the definition. Third thing, we just saw what is a junction, what is a node. Now fourth point is KCL is based on conservation of charge. KCL is based on conservation of charge. The charge entering per unit time will be same as the charge leaving per unit time. So this is nothing but amount of charge entering per unit time, okay, is equal to the amount of charge leaving per unit time. Okay, so that is why we say it is based on conservation of charge. Suppose I entering is equal to I leaving, we say sum of I entering is equal to sum of I leaving. So we can write in this way dq by dt. Okay, all entering current, then dq by dt leaving. So here this is nothing but conservation of charge. Whatever charge incoming, entering, all will be leaving. Clear? So I have mentioned about the book H.C. Verma. So H.C. Verma sir used to give a clear example. This is nothing but a simple example. Okay, if this is a pipe, water enters. So from this, okay, if this is a pipe, water leaves. Okay, so this is how much water enters, that much water will be leaving through two pipes. So just like that only, what? Current also, or charge also. Okay, this is all about KCL, the fundamental theory. Now we will start doing problems. Okay, so this is the first question, and this question is 2019 JE problem. Okay, 2019 JE problem. We can solve this. So what they have given is I1, I4, I5. These values are given. I2, I3, I6 we need to find out. So what you can do is just pause the screen. You try to find out. Okay. Basic concept you know. So based on that, try to find out. Okay. So get the answer ready. I will try. Now I1 is given. Okay. What is I1? I1 is given as minus 3 ampere. Dear students, if they give minus 3, okay, that means that whatever is direction given in the question, given in the diagram, the real direction will be opposite to that. That is its meaning. Now here I1 is given as this direction. Again there they have given a negative. So first thing which we need to understand is real direction will be opposite to the given. So 0.3 ampere will be flowing in this way. Okay, so I can take this as 0.3 ampere. Okay, that is I1. What about I4? I4 is given as 0.8 ampere. Okay, then they have given I5. I5 is 0.4 ampere, that is same as I6, 0.4 ampere. Yes. Now we need to find this. Okay, so one thing which we can understand is this is a junction. So I2 is entering. This is split into 0.8 ampere and 0.3 ampere. So 0.8 and 0.3 if they need to leave, so the sum of this must come here. So do it simply, no need to write and scratch and see. 0.8 plus 0.3 will be 1.11. So directly we can take 1.1 ampere. Correct, no? 1.1. Okay, so this is done. So this option gone. Now next we can find I3. Where is I3? This is I3. So 0.8 is coming here, 0.4 has gone here. So definitely what must be entering here? This must be what? 0.4 ampere. Okay, so then what we need to find? Okay, just we will verify. I6 also we need to find. I6 already given. Okay, same. I5 is same as I6. So that is given as 0.4 in both the cases. Here this is minus or plus, that is the only difference. So 0.4 is coming, 0.3 is coming, 0.4. So 0.4 plus 0.4, 0.8. 0.8 plus 0.3, definitely this is going to be 1.1 ampere. So without any doubt, we will be able to answer as option A. Clear all of you? So hope you also got the same answer. Take this another question. Okay, a circuit is given. This node voltage is also given. This node voltage is given as 20 volt. Okay, here. And 3 resistances. This is a switch. Another node 5 volt. Question is, find the current passing through this switch when it is closed. Okay, so at some point of time, this switch will be closed. What will be the current that is passing through the switch? That is the question. Okay, so can you try? Just can you pause the screen and just try this, how to do? Okay, clear? Got the answer? Okay, now here let me tell you, just suppose if we connect a resistance to a battery. Already I have told you this concept. Once again I am just reminding you. Okay, just a simple recap. If this is 10 volt and if this is 2 ohm, we all know the current passing through this will be 5 ampere. And already we have said this is 10 volt and this is 0 volt. So what we say, this is also 10 volt. Here also this is going to be 10 volt. 0 volt. Here also 0 volt. 0 volt. 0 volt. We can say this is also 0 volt. In between there is no resistance to eat the voltage. Okay, battery will supply energy to the charges, and so battery will be able to provide EMF or some voltage to the circuit, or potential difference will be created by the battery. So that potential will be taken by whom? These resistances. So when there is only one resistance, we can say 10 volt here, 0 volt here. Actually what is current? Current is nothing but change in potential difference divided by R. So what change in potential difference? This 10 minus 0. Okay, 2 terminals are there. This is one terminal, this is another terminal. So here it is 10 volt, here it is 0 volt. So actually current is nothing but change in potential difference, change in potential, that is potential difference divided by R. So 10 minus 0 divided by 2, then we get 5 ampere. Clear? We need not take this always like this. If this is 20 volt and this is 10 volt, in this way also we can consider this battery. Battery's task is to just make a potential difference between its terminals, no other thing. So if we take like that, then I can say this is going to be 20 volt and this is going to be 10 volt. Then what will be the current? Current will be like 20 minus 10 divided by 2. What is the answer of this? Yeah, 5 ampere. Same value you will be getting. Clear? So this understanding is important. If we get a resistance, current is not simply V by R. Current is actually delta V by R, or change in potential divided by R, or potential difference divided by R. This concept we should digest this. Clear? Once if this is okay, then okay, note it down. If you do not know, please note it down. Okay, now I am moving to the question. Right, so now what we are going to do is, there is a node here. Okay, there is a node here. We do not know its voltage. Simply we are going to put this as V. Now grounded, if we ground a wire or if we connect a wire to earth, this earth is always at zero potential, zero voltage. Okay, whatever current is there, any amount of current can be taken by earth. That is why if there is current in this, if I touch and if I don't wear a shoes or chappal or insulator, I will become a closed circuit because earth is there. Current, any amount of current can be gone to earth. Any amount of current can be sent to earth. So if we touch something, if current is there, if I have not, if I don't have sandals or chappals, then what will happen? Current will pass through me. There will be a closed circuit formation. Okay, so earth is at zero voltage. Okay, so any amount can be passed. Now what we need to do is, if current will be flowing in this direction, or current will be flowing in this direction, or current will be flowing back or flowing back, we don't have any idea. Clear? We don't have any idea in which direction current is going to flow. So if you take 5 volt minus V by R, 20 minus V by R, or 0 minus V by R, whatever way we take, we are going to get the answer ultimately. Okay, so what we are going to do is, we will apply Kirchhoff's current law here, KCL. We will apply KCL. What is KCL? Suppose if I consider, I am going to consider all as leaving current. If you want, you can consider all as entering current, or if you want, you can consider some as leaving, some as entering. Any way we want, we can take. Okay, if we take it wrongly, in the answer we will get a negative. So we will be able to judge the current direction. Okay, if we take it correctly, we will be getting positive. So I am following a sign convention. You can also follow that in order to avoid confusion. What I will think is, this voltage I will be considering as a superior voltage, means voltage greater than all other. Need not be. Okay, just we are considering like that, and I am going to approach. Okay, so what I am going to do is, here all the currents will be leaving from this node. I am going to consider this as all the currents are leaving. So I1, I2, I3, all the currents are leaving. We are going to take like that. Okay, all the currents cannot be left from a junction, but we are considering like that. Okay, so when we apply KCL, okay, I am going to consider V is at a higher potential. So V minus 5 divided by 4 plus, I am going to consider leaving current as positive. Beginning itself, entering current, I took it as negative because I am comfortable, I am just habituated in that way. Okay, plus V minus 0, this is 0, divide by 2. Okay, just like previous battery case, plus V minus 20 divide by 2 is equal to 0. That is, here nothing, we are just taking I1 plus I2 plus I3 is equal to 0. Digested or not? Please read this. Understood or not? Okay, clear all of you? Just considering, just like in this case, if we take a resistance, this is V, this is 0, so V minus 0 by R. Same way we are considering this as leaving current, so V minus, so just like V minus 0 divided by R, we are going to take V minus 5 divided by R, 4 ohm here. Same way V minus 20 divided by 2, V minus 0 divided by 2. Okay, sum of all the currents are leaving, I am considering like that. Okay, right, fine. So now if we take the LCM, I will be getting 4. So V minus 5 plus 2V plus 2V minus 40 divided by 4 will come that will 4 will go to 0, 4 will go vanish 0. So this is going to be 5V is equal to what? 45. So V is going to be 9 volt. So I got this node voltage as 9 volt. This node voltage I got it as 9 volt. So this is nothing but 9 volt. Clear? Now suppose if we need to find the current through this. What current is this? Just simply if we take it as I3 is equal to 9 minus 0 divided by 2. This is going to be 4.5 ampere. Just I need to find only this one. So I found this is nothing but 4.5 ampere. Suppose if you want to find any of these, we will find that also. Just see, I1 is equal to 9 minus 20. That is how we have taken as leaving current. 9 minus 20 divided by 2. What is this? Minus 11 by 2. How much is this? This is minus 5.5 ampere. I am getting a minus. So the actual direction of flow will be in which direction? This will be the direction of I1. Exactly how much? 5.5 ampere. So I took wrong potential. I took V as superior to all other potential, which is wrong. Okay, but I got the correct answer. So anything you can take. Okay, no worries at all. What about this? I2. If we try to find I2 is nothing but 9 minus 5 divided by 4. 9 is greater than 5, definitely we will be getting positive value. So how much is this? This is 4 by 4 is nothing but 1 ampere. So 1 ampere is leaving, no worries, which is correct. So 1 ampere is leaving here. Now look at, see, 4.5 ampere is coming in this direction. So 5.5 ampere is coming. 1 ampere went to that side. 4.5 went to this side. Total is 4 plus 1, 5.5 ampere. Clear? Clear all of you? Okay. So this is not a JE problem, but similar question has come with changed values. Okay, not exact values. I have taken JE problem only, but I have changed some values. Clear? So exactly similar problem has come in IIT JE also. Clear? Note it down. Okay, take another question. Okay, 11 volt, 4 volt, 3 volt, 2 volt. All terminal voltages are given. We need to find the current through 12 ohm. Okay, we need to find the current here. Okay, so pause the screen, try yourself. Okay, try yourself. Pause the screen and try yourself. Okay. Okay, so hope you got the answer. Okay, right. So what we are going to do is, we do not know this junction voltage. Assume this as V. Just take this as greater than all other. Okay, if you want, you can consider that as smaller. Whichever way you want, you can take. I am following this method. I used to take this as superior voltage. So V minus 11 by 12 plus, before that, just see, once if you start doing these problems, we need not mark the currents and all. It's fast, in fast mode we will be able to do. Okay, so just for understanding, I am marking the current I1, I2, I3, I4. So just do enough number of problems so that you will be having much pace, tremendous pace you will be able to achieve. Fatafat you will be able to solve the problems. So just for understanding, I am just putting all these. So I1 plus I2 plus I3 plus I4 is equal to 0. So considering all as leaving currents, considering this junction voltage as greater than all other terminal voltages, need not be true, my children. It need not be true, but we are taking like that. Okay, it's a method to solve the circuits. So we are taking like that and we will be approaching. If something is wrong, negative will come, so that we will change the direction. Clear? So all current I1, I2, I3, I4 all are, I am considering this as leaving currents, okay, taken as positive, and this V is taken as superior voltage, okay, superior voltage, okay, considering greater than all other, okay, just for solving purpose, okay, just considering this as superior voltage. Clear? Okay, right. Now V minus 11 by 12 plus V minus 4 by 8 plus V minus 3 by 4 plus V minus 2 by 6 is equal to 0. Clear? Okay, done. So now what will come? LCM will come as 24. LCM will come as 24. Can I erase this? Shall I erase this? Okay, suppose if you have any confusion, please note all the datas which I am giving. Okay, clear? So considering LCM as 24, we will be getting 2V minus 22 plus 3V minus 12 plus 6V minus 18 plus this is 6, 4V minus 8. Okay, clear? Right, is equal to 0. 24 will go to this side, that will be vanished. Okay, so what we are getting? 10, 15V is equal to how much? 22, 34, 44. How much will be getting? 18. This is 30. 30. Okay, here 60. Okay, so voltage is equal to 4 volt you will be getting. Clear? Once if we get 4 volt, the remaining things are easy. Okay, just we got here 4 volt. So what is I1? So suppose now if we try to find I1, I1 is equal to, simply if we take 4 minus 11 by 12, we know this is smaller than this, so directly I1 if we want we can find like this, 11 minus 4 divided by 12, how much is coming? 7 by 12, okay, ampere. So even if we take in the reverse way, we will be getting minus 7 by 12, indicating that the leaving current direction we have taken is wrong. Current will be actually entering. Clear, all of you? Clear? Right, note it down. Okay, now slowly we will increase the level of the question. Now here, see this question. Okay, we don't have any resistance in this branch. Okay, now here we need to find the branch currents. Suppose nothing is given, no branch currents are given. So I along 2 ohm, okay, I along this 2 ohm. What about this I? All these things we can find using this method. So just try to find the current in all the branches. Just pause the screen, try for yourself. Okay, then we will see the solution. Clear, all of you? Right. So look at this, students. Here this is 10 volt, means actually this is 10 volt. Okay, already this is given as 10 volt. We can take this terminal as 10 volt and this terminal as 0 volt. We can consider 20, 10, 5 minus 5. In all these ways we can take, but why should we complicate the calculation? So easiest method we will be taking. So we can consider this as ground. Okay, 0 volt, this will be what? 0 volt. 0 volt. Now this 10 volt, here no resistances. Okay, clear? So this is 10 volt, this is, so finally what will happen? This node voltage is 10 volt. Clear? See, take this battery and take this battery. Suppose if I draw, okay, just simply leave this resistance just to find the polarity of the battery. Okay, do you agree this battery is connected like this? A resistance is here, just ignore it. Take this polarity. I plugged here. I plugged here. Now see, look at the polarity. If I connect like this, okay, this positive is connected to positive. Positive is connected to positive. Clear? Do you agree? Suppose if this battery emits current, if this sends current, this positive terminal also sends current. Correct or what? This will not happen like this, but effectively what will happen is, if this is 10 volt and if this is 4 volt, what will happen is these two will, these opposite polarities will behave in such a way that finally what will happen, effectively this will become 6 volt since the polarities are different. Suppose if we connect like this, positive is connected to negative, this also will contribute current, this also will contribute current. Here this is opposing, but this is here aiding. So if this is 10 volt, this is 4 volt, finally what will happen, these batteries will become join, and effectively what will happen, this will become 14 volt battery. Clear? If the batteries are connected with the same polarity, that will add, and in the opposite polarity, that will nullify the effect of the other. Clear? So understand this. Okay, note down. Clear? Okay, now come to this question. Okay, all these things are important tips. Okay, just by doing problems only, you will be able to catch all these things. Okay, now look at this part. If this is 10 volt, then this is also 10 volt. So this is positive is connected to positive, so we can say this is opposite polarity. So effectively what will happen, 10 minus 4. Okay, first problem I will show you. Okay, so this is I1, this is I2, this is I3, we will take just for understanding. After that nothing is required, fatafat we will be able to solve all these. Okay, so I am going to take 10 minus 4 is 6 volt, 6 by 2. Okay, so I1 is equal to what, 10 minus 4 divided by 2. So 6 by 2 is equal to 3 ampere. Okay, so this is going to become 3 ampere. Same way if we take I2, 10 minus 0, here it is 0 volt, 0 volt, 0 volt. So 10 minus 0 divided by 2. So this is going to be 5 ampere. So we can measure this as 5 ampere. I took this as leaving current. So if 5 ampere is leaving, 5 ampere is leaving like this, then 8 ampere must enter like this. So we can take this I3 as 8 ampere. Clear? Clear? Okay, so note it down. Now just see, without all these writings, how to look at the circuit and tell. Okay, okay, just a simple circuit, 4 volt, 10 volt. No need to solve all this. How you should calculate, I will tell you. 10 minus 0, 10 minus 0 is 10, 10 divided by 2, 5. 10 is bigger or 0 is bigger? 10 is bigger, so 5 ampere will be leaving. 10 minus 4, 6, 6 by 2, 3 ampere, 3 ampere. Which direction? 10 is bigger or 4 is bigger? 10 is bigger, so 5 ampere will be leaving. So this is going to be 8 ampere. Clear? So remaining all those problems we will be solving like that. Okay, note it down. Okay, take this problem. No need to write I1, I2, I3 and all. Just directly we will be able to do. Okay, pause the screen and do yourself fast. Okay, do yourself, get ready with the answers. Okay, now I am going to do. Okay, this is 4 volt. No resistors in this branch. If resistor is there, story will change. 4 volt, 4 volt, 4 volt, 4 volt. This is positive. This is also positive. So 4 minus 2, how much? 2 volt. 2 by 2, 1 ampere. 1 ampere is the current here. In which direction? 4 is greater or 2 is greater? 4 is greater. So 1 ampere will be going like this. 4 volt. 4 minus 2. This is positive. This is also positive. So 4 minus 2 is 2. 2 by 2, how much? 1. So 1 ampere. 4 is bigger or 2 volt is greater? 4 is bigger. So 1 ampere goes like this. So definitely this must be 2 ampere. Clear? Easy thing. No need to put all these things. If there is no resistance in the branch, 4 volt, 4 volt, 4 volt. 4 minus 2 is 2. 2 by 2, 1. Since this is greater than this, leaving current. 4 minus 2, this is also positive, this is also positive. So minus, subtraction. Like poles, repel. So this is also positive, this is also positive. So 4 minus 2, 2. 2 by this 2, 2 volt by 2 ohm is how much? 1 ampere. Since this is greater than this, leaving. So from this we will be able to do. Clear? Okay, see students, this is the next question. Okay, find the current in all the branches. Find the current in all the branches. Just pause the screen and solve this. Find the currents in all the branches. Just pause the screen and try to do. Done? Fast. Okay, just the same method. Okay, so any branch without resistance? Yes, this branch is without resistance. So this is going to be 10 volt, this is going to be 0 volt. So this will be grounded. 0 volt. 10, 10, 10, 10. This is going to be 10 volt. So this is positive, this is negative. Positive, negative. So unlike polarity, they can be added. So 10 plus 4, 14. 14 by 2, 7 ampere. So definitely the current through this is 7 ampere. So which is greater, 10 volt or minus 4? 10 is greater, so 7 ampere will be leaving from the node. Clear? Okay, so 10, this is positive, this is also positive, this is also positive. 10 minus 2, 8. 8 by 2, 4. So 4 ampere will be in this branch. 10 is greater or 2 is greater? 10 is greater, so 4 ampere will be leaving. What about this branch? 10 minus 2, 8. 8 by 2, 4 ampere. 10 is greater than 2, so 4 ampere. What about this branch? This is going to be 0 volt. 10 minus 0, 10. 10 by 2, 5 ampere. 5 ampere. 10 is greater than 0, so 5 ampere will be leaving. So 7 plus 5, 12. 12 plus 4, 16. 16 plus 4, 20. So 20 ampere will be delivering from this battery. Clear, all of you? Clear? Clear? Okay. So no need to write too much and waste your time. Just put the voltage. If there is no resistance, put in the node voltage. Once if you get from the node, fatafat, you will be able to answer. Okay. Since this is negative, we are adding. Remaining all are positive, so we are subtracting. Clear all? Okay, take this question. How to do this? Pause the screen and try yourself. Okay, just pause the screen. Try. Same method. Okay, got the answer? Shall I try? Okay, so this branch doesn't have any resistance. So this voltage will come here. So see this is minus 10 volt. This is minus 10 volt. We can take this as 0 volt. This is negative polarity. So we will consider this as 0 volt. Clear? If we want, we can take this as 0 and this as minus. But why should we complicate the calculation? So we took this as 0. This is nothing but minus 10 volt. So this is minus and this is 2. So minus 10 plus 2, what will happen? Minus 8. So minus 10 plus 2, minus 10 plus 2 is nothing but minus 8. So 8 by 2 is 4 ampere. 4 ampere. So 4 ampere will be in the branch. Which is greater? 2 volt is greater than minus 10. So 4 ampere will be flowing like this. Clear? Now take this one. Minus 10 and 2. This is negative, this is positive. So minus 10 plus 2 is nothing but again minus 8. Minus 8 by 2 is 4 ampere. Since this is greater, 4 ampere will be flowing like this. Clear all of you? Minus 10 plus 4 is nothing but minus 6. 6 by 2 is 3 ampere. Which direction? 4 volt is greater than minus 10. So 6 by 2, 3 ampere will be going like this. So 4 plus 4 is 8. 8 plus 3 is 11. So all these will be flowing in this direction. Clear? All the branch currents we got. Understood? Clear all of you? Just take the voltage of a branch which doesn't have any resistance and put it there. Okay, once if we get node voltage, we will be able to do. Clear? How to do this one? Find all the branch currents. Okay, find all the branch currents. Pause the screen. Find all the branch currents. Okay, clear? Okay, got enough practice. Okay, understood now? So no resistance in this branch. This is 10 volt. We can consider this as 10 volt. This is 0 volt. This is also 0 volt. Okay. Now 10 minus 4, 6. 6 by 2, 3 ampere. 10 is greater than 4 volt. So 3 ampere will be leaving. Correct? No? Then what about this? 10 minus 6, 3. 3 by 2, 1.5. Okay, 10 volt minus 6 volt. Both are positive. This is also positive. This is also positive. So we will subtract. 10 minus 6 is, 4. 10 minus 6 is 4. 4 by 2 is 2 ampere. 2 ampere will be in this branch. Okay, 2 ampere. So in which direction? 10 volt is greater than 2 volt, 6 volt. So direction will be this. What about this one? 10 minus 2, 8. 8 by 2 is 4. 4 ampere. 10 is greater than 2 volt. So leaving like this. Okay, how to solve this? Okay, same way we will make this as 10 volt. Then 10 minus 6, 4 by 2, 2 ampere. 10 minus 2 is 6. 6 by 2. 10 minus 2 is 8. 8 by 2 is 4. 10 is greater than 2. So 4 this way. Same way this thing. 10 minus 4 is 6. 6 by 2, 3. So all these things putting together. 4 plus 3, 7. 7 plus 2, 9 will be coming out of this battery. Clear? Clear all of you? Okay, so students, this is just fundamentals. Now what happens if a resistance comes here? When a resistance comes here, we won't be able to put directly this 10 volt there. Okay, then we will have to find this node voltage. So that process is nothing but nodal analysis. Okay, from Kirchhoff's current law, nodal analysis is the method to find. So once if you understand nodal analysis, very complex circuits also you will be able to solve within few seconds. Okay, that we will see in the next class. So nodal analysis, Kirchhoff's voltage law, we will see in the next class. So till then, practice all these questions and get ready. And normally when we get a question in the exam, resistance will be here. Okay, resistance will be there. This method will help us in solving some problems. When resistance comes, we will have to find nodal analysis. Same thing only, one voltage minus another voltage divided by resistance. Only thing will come, this node voltage we won't be knowing. Okay, so that also we will have to do. Just I will show one diagram like that. Suppose, just I will say that method also. So along with this it will be easy to learn. Now here we cannot put any node voltage here. What we will do? We will consider a V there. So just like in the previous case, just like how we considered we will consider this V as superior to all. So here current will be leaving, current will be leaving, current will be leaving, just like that we can take. And even if we don't write this also, we can take in this way: V minus 4 by 2 plus V by 2 plus V minus 4 by 2 is equal to 0. V minus 4 by 2, consider this as positive, just like this we have taken, we are quite sure. But this thing we are not sure, but we will consider like that. So V minus 4 by 2, V by 2, consider this as ground. Then V minus 4 divided by 2. So if we solve this, we will be getting 1, 2, 3. 3V, this 2 will go here, this will become 0. So this is equal to what? Minus 4, this will become 8. So V is equal to 8 by 3 volt. 8 by 3 volt. Clear or what? Okay, so this is nothing but 8 by 3 volt. Once if we know that, then remaining all the currents can be found easily. Clear? So this is nodal analysis. Okay. So even if we get one more branch, 2 nodes will come, we will have to take 2 equations. So the same thing which I have explained today, we will revise in the next class, then we will proceed from there. Okay. Okay students, thank you so much. Hope you enjoyed the class. Good luck, goodbye.